Hello, my name is Bob D. Hilster, and I am your particle model guru. Today is the second part of a three-part video. The first one I released earlier is about the candle, and today we're talking about the light bulb. This is a picture of a light bulb that's been burning for over 100 years. From the ABC News, and what they report is that in Livermore, California, is home to what residents say is the world's longest burning light bulb, made by the Shelby Electric Company of Ohio. It's been shining bright without a flicker at the town's firehouse since 1901, and the filament is still working. The original atoms of the filament are still there. So where does the light come from? In the candle, I bet when we did that one, it's the methane and oxygen that combust and the G1 particles are released as light. In the end, the candle is gone. In the light bulb, if the G1 particles came from the filament would be gone in a very short time. The bulb at the firehouse is still there over 100 years. So where does the light come from? There's a link here, and in this link, actually has a question which I retyped in the middle of the screen, which asks the question, or yes, the number of electrons delivered to the, this is really an answer, sorry, not a question. The number of electrons delivered to the average home through an energy company is 0. And this is part of their answer in this link. Electrons are not delivered to homes. The source of electrons that provide energy in homes is actually the electrical conductor itself. So what does the company provide? And we're going to go into that in some detail here. So let's look at the standard answer. What the electrical company says is they provide a AC voltage. That's down here, 110 volts at this terminal, which they actually is the technical name for that is EMF force. Now, one of my very early videos, I said, I don't know what EMF is. I know what the words say. You can read this backwards and understand what it says. The EMF is a force, F, that moves electrons. It's a force that moves electrons. It tells you what it does, doesn't tell you what it is. And when I get to the electrical discussions, I will go into that a lot more detail. But they claim that the electrons move the free electrons back and forth. In the copper wire, the standard answer is that you got atoms in the wire, and there are free electrons. And these 3 electrons, they hop from hole to hole at a very slow rate. Hop, 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 hop. One way, and then they're going to hop, hop, hop the other way. And this hopping is what excites the electron, the atoms in the filament, just like I described with the candle. When the light bulb is on, the atoms of the filament release. See, this is the hopping electron here coming in, it hops it, excites it. Electron jumps up, falls back, releases energy, creates a photon. And so, yeah, if you like this solution, if this is, you agree with this, you got your answer. These are the 3 steps. A particle collides with and excites the atom, whatever that means, and the electron jumps to a higher level, falls back, releasing energy. And my question is, again, as I said last time, can energy create a photon? Not. I won't go through the whole thing. If I can't find it in nature, it's not real. If it comes from math, it's not real. So how can a photon be made from nothing? Okay, well now the particle model is different. I'm going to claim right out front that G1 particles come from the power company. And they move through the wiring at speed c. Now, every 60 hertz coming into your home says that every half cycle is about 8.3 milliseconds. So I'm going to try to make a specific point here. I took a sine wave with an amplitude of 10, and I calculated its value at 0 degrees, 22.5, 45, 67.5, and 90, and so on, because it just repeats its values. And I'm going to kind of quantize the flow of G1s through this wire. So now you're going to watch my hands, if I can do this right. And what you have on the on this side, it starts on the for example, a voltage side, but both of them are at 0. At one point, they're both not moving anything. But then, in a short period of time, you get 4 G1 particles moving. Then you get 7, then you get 9, then you get 10, and 9, and 7, and 4, then down, and then they're both 0 again, and then this one starts 4, and 7, 9, 10, and down again, pushing them back and forth. It takes 8.3 milliseconds for this cycle to happen, another 8.3 for that to happen, and you have pushed G1 particles through, or I shouldn't say push, you have moved G1 particles through the wire and through the filament. But they move at or about speed c. They're moving very fast. They're not hopping. They're not hopping from hole to hole. They're flowing through the open space of the wiring. And in that short distance, you're down in the microsecond amount of time. So when this one starts, as soon as you send them, man, they're already around the other side. And as soon as you send it, they're already around again. And you send it again, they're gone around. So this whole idea is much different than what they're saying. And of course, the electric company sends these things not in groups of 4, 7, 9, and 10, or whatever the value might be. It's more of a continuous flow. But this was used as an example. Okay. So the filament gets hot because the G1 particles hit atoms of the filament and they vibrate. The filament does not combust because the filament is inside a bulb. There's no oxygen inside. There's no combustion. And that's why a filament in a lipo can go on for a long period of time. And when you build it right and build it well, it can last over 100 years. What Edison did, he finally found a filament that would heat up and cause the atoms to vibrate at a rate which matches the wavelengths of white light. In other words, these atoms have to be vibrating at a rate that'll send out wavelengths in all directions that match the wavelengths of anywhere from blue to red and in between. These things are quite random. A white light is more like a random flow of bursts of particles. Okay, so here's what I'm also going to visualize. The atoms of the filament push out the G1 particles that come from your electrical outlet. So let's take this. Let me do it this way. Okay, I got an atom vibrating back and forth, and as the atom is vibrating back and forth, it moves outward away from the center of the filament, or it moves back. The flow of G1s coming through the filament get pushed out. When the atom is moving back, it's not pushing any out. Some may leave, but there's not really pushing out. So I can visualize that I'm going to get pulses of G1 particles coming out of the filament. And that's what I say in the middle there. As atoms move outward, it pushes G1 particles out of the filament intervals that match visible wavelength. At the moves inwards, only a few or no G1 particles are pushed out. If these G1 particles leave the light bulb, then the power company must be supplying the G1 electrons. They have to be coming from them. Okay, now this is an ideal case. I've shown you this before. In an ideal case, you have a perfect sine wave. Well, that's not the case that I just described. In fact, what I described was clumps get pushed out here and clumps get pushed out here and very little in the middle. And it doesn't really matter. It doesn't matter that it's not a perfect sine wave as long as the wavelength is the wavelength of whatever light we're looking at, part of the white light. If this is the green wavelength, your eye will detect green, the green part of the white light, because the wavelength, these groups are going to push on your eye, and hit that green cone in the retina of your eye, and constantly, and you're going to see green. It could be clumps. It doesn't have to be a perfect sine wave. Now I'm going to review the standard answer for the candle was that the electron is excited by a particle. The atom is, I should not have said electron. The atom is excited by the heat particle, and when it gets excited, it creates a photon, and I can't accept that. The particle model says the wick heats up the wax and combusts, and the atom vibrates, pushing out the G1 particles that are orbiting. We have G1s orbiting, and we have G1s out. The G1 replaces the orbiting electron and the photon. I've said that way back when, that the G1 particle replaces the electron, the photon, and the graviton. I'm not talking about gravity here. Okay, that's the candle and the light bulb. The standard answer is the electron that's in the wire, that your conductor wire excites the atom and it creates a photon out of energy. Particle model says no. The G1 from the power company, as it moves, zips back and forth around the conductor, heats the filament, the atom vibrate and push the G1s out. You have G1s coming in, you have G1s going out, and the G1 replaces, again, the electron and the photon. In both of these slides, I'm trying to make a point that this is a very much simpler model. To explain things are much more easy to understand, and it's simpler. Okay, another advertisement here. If you like my videos, just click on the red subscribe button and you will get emails when I release a new video. Or you can just go to the website and you can pick any one or all of the videos I have released. And if you don't like the emails, you can unsubscribe at any time. My name is Bob D. Hilster, and I am your particle model guru. Tune in next time when I explain more of the universe using the particle model. Thank you for your attention.